Using the student height dataset, or the student survey again, what you can do is test formally for normality. So SPSS has two different tests. One is Kolmogorov-Smirnov, the other one is Shapiro-Wilks. It also calculates something called the QQ plot. So Kolmogorov-Smirnov and Shapiro-Wilks actually look at the QQ plots in order to determine whether there's a difference or not. A QQ plot is a quantile plot. So what you're doing is comparing the first 10% of your actual data in your dataset to a theoretical, hypothetical, normally distributed set of data with the same mean and standard deviation as your experimental dataset, your experimental sample, and seeing if the two things are the same or different. So if your data is normally distributed, if you create this theoretic, hypothetical normal distribution, then the first 5% of the data will come to exactly the same position as the first 5% of your data in the real data set, and so you'll get a perfect match. So the QQ plot should be a perfect diagonal straight line if your data is normally distributed. So to do these analyses, go to Analyze, Descriptive Statistics and Explore. I'm going to look at the height data, and you go to Plots and you click on Do the Normality Plot. So I'm going to switch off the histogram and I'll switch off the box plots to do none. So I'm just going to focus on the normality plot, because otherwise you'll get an awful lot of plots that makes it a bit confusing. And press continue, and I just want to do plots. Now if I look at my output, I get this. What's the height in meters? There's 666 people that are valid, 97.7%. There are 16 missing values, which is 16%. So here is the QQ plot. Now if it was perfectly normally distributed, you wouldn't get any variation off at the bottom here or at the top. It would just go in a perfect diagonal. So this has a bit of an S-shaped curve. Now this happens fairly often, and just because large and small values, there tend to be a few outliers. So these values are worth going to look at, because it's quite possible that people are wrong about their heights. This is the detrended one, so this is the difference between this line and what actually happens. So you see a lot of the time around the middle there's very little deviation from that QQ plot, but there's big deviations at the very tall people and the very short people. Now above that there's a table with the test of normality. So here is the Kolmogorov-Smirnov and here is the Shapiro-Wilk. Now if these values are below 0.05, then there is a significant deviation from normality, which here you can see because of these very sharp tails, this very strong S shape in the curve. If these things are above 0.05, then there is no difference between your data collected and a normally distributed set of data. Now when looking at the histogram for this set of data, I can go and do, well, let's just draw it as a graph. So if I do histogram, a regular histogram, so height in meters, histogram, press OK. So the histogram is showing normal distribution apart from these horrible tail messes which look like they're unreliable data points. So here you have to make a decision whether you're going to treat this species as outliers and exclude those set from your data set, because the histogram really strongly suggests that it is normally distributed, even though Kolmogorov-Smirnov and even the QQ plot are saying you've got problems because of these particular values. But you're talking about 7 tall heights and 5 or 6 shorter heights that are completely changing your distribution. So now you have to make a decision as to what you're going to do with that set of data. Do you think it's genuinely not normally distributed, or do you think something a little bit strange is happening? So somebody 2.5 meters tall, that's a very tall person. It's also worth looking in this particular data set because not everything was included. So if you go back to variable view, what are the missing values? So there's missing values in height, so anything that has a height of 1. There's a lot of they've been defined as 1 is the discrete missing value. So some heights have been changed to that. This has happened because people have put values in the survey which are difficult to interpret. So they've given numbers which can't be numerically changed into something. That's not perhaps an ideal missing value, because 1 is something that could potentially exist. You could have somebody's 1 metre tall if you had children in your data set. It's always best to have a missing value that is well outside the possibilities of your data.